Bitcoin Cash now has advanced smart contracts that scale. On May 15, 2023, miner-validated tokens were added to the Bitcoin Cash protocol. You can now mint custom assets on the BCH blockchain, which can then be sent and received just like Bitcoin Cash itself. In addition to enabling the token use cases you're most likely familiar with, like NFT art and initial coin offerings, the upgrade also leverages tokens to enable decentralized applications rivaling the capabilities of blockchains like Ethereum. How's that possible? Stick around. While Bitcoin may not be the first chain you think of when you hear the terms smart contract and decentralized finance, it's important to remember that the Bitcoin network launched with its own scripting language. Using a predefined set of functions called opcodes, users could make customized rules for what will make a transaction valid or invalid. Those opcodes included basic math operations like add and subtract, logical operations like if and else, cryptographic functions like hashes and signature checks, and some other more esoteric tools for interacting with Bitcoin's stack-based virtual machine. Don't worry if that last bit goes over your head though. What's important is that we recognize Bitcoin was conceived and released with programmability in mind. But Bitcoin smart contract development largely took a back seat when Ethereum was launched in 2015, and understandably so. While Bitcoin contracts were limited by the functions available in the scripting language, Ethereum smart contract developers could implement any logic they wanted. Ethereum does have its downsides though. While the Bitcoin network only has to keep track of which coins haven't been spent yet, the Ethereum network needs to keep track of an entire virtual computer with various programs running simultaneously and potentially interacting with one another. That architecture makes scaling the Ethereum network to process more transactions very difficult. And when demand for transactions is higher than the network capacity, users are forced to pay high fees to outbid one another. Ironically, while Bitcoin's architecture scales exceptionally well compared to Ethereum's, a group of Bitcoin developers decided the Bitcoin network should only be allowed to process a small number of transactions at a time. Disagreement about that direction led to the Bitcoin Cash fork in 2017. Since Bitcoin split into BTC and BCH, Bitcoin Cash has upgraded its scripting language several times. For example, many opcodes originally disabled in 2010 were re-enabled in 2018. Several new opcodes were added that year too, including opcheck datasig, which allowed BCH smart contracts to use trusted sources of information from outside the blockchain. That data could include current exchange rates for futures contracts or the status of a delivery for escrow contracts. One of Bitcoin Cash's most important script upgrades came in 2022 with transaction introspection. Introspection opcodes allow smart contracts to restrict not just whether coins can be sent, but also how those coins can be sent. For example, you might keep your savings in a smart contract that doesn't let you withdraw more than 5% of the balance per day unless your financial advisor co-signs the transaction. These upgrades enabled a surprising number of financial products and features, but there were still applications that would have been impractical or impossible to implement on Bitcoin Cash. There was still one piece of the decentralized finance puzzle missing, and that piece was, you guessed it, protocol-level tokens. With the addition of miner-validated tokens, Bitcoin Cash can now host much more complex financial products, like decentralized exchanges, or DEXs, decentralized autonomous organizations, or DAOs, and even sidechain prediction markets, all without sacrificing its excellent scaling characteristics. The details are a little technical, but I'll try to give you a general idea of how it works. Let's shift back to Ethereum to start. Just like how programs on your computer can read data from your hard drives and interact with other programs, Ethereum transactions can read data from the Ethereum blockchain and interact directly with other smart contracts. A technical way to describe this setup is to say that Ethereum transactions have access to Ethereum's global state. While that means processing transactions is computationally expensive, it makes complicated arrangements easier to implement. Bitcoin Cash transactions, on the other hand, are executed atomically, that is, independently from all other transactions, past and present. Without access to Bitcoin Cash's global state, we need another way to represent and keep track of the various data structures used by complex smart contract applications. That's where tokens come in. While you might usually think of tokens as representing assets, Bitcoin Cash's implementation generalizes the concept. Bitcoin Cash tokens are defined by small commitments of data and a category. The category allows Bitcoin Cash tokens to prove independently that they were issued by a given contract, and the data defines how the token interacts with the contract. By cleverly arranging and interconnecting multiple contracts that can issue and redeem tokens, we can create DEXs and DAOs whose current state is represented entirely by the balances of those contracts, the locations of their issued tokens, and those tokens' properties. But in this case, interacting with the DeFi application doesn't require knowing about all the other tokens it's issued. Your tokens carry the unforgeable data on how you can interact with the application, and that's all you need. Instead of tracking state globally, Bitcoin Cash smart contracts track state locally. For more information, take a look at the CashTokens proposal. As a final note, it's important to understand that you will not be able to copy and paste smart contracts from Ethereum to Bitcoin Cash, like you could from Ethereum to other EVM chains. While you may be able to build similar applications, the design process is completely different. Think of it like how both the carpenter and a 3D printer can make a birdhouse, but giving a carpenter a list of coordinates, extrusion rates, and some plastic filament will get you about as far as leaving a 3D printer alone in a woodshop overnight. So it will take time to build the infrastructure that Ethereum users take for granted. What applications do you think will be the first to gain traction? Let me know in the comments, and be sure to subscribe for more videos like this one.